Hey everybody, my name is Ben Ringle. I am a part of UIUC Chess, and today I'm hoping to explain to you the wonderful feature in Dragonfly called Segmentation Wizard. Segmentation Wizard is an incredibly useful tool for developing very quick, fast models, deep learning models that use neural networks that can be used for segmentation. It can also be used for other things like super resolution or noise removal. However, in my examples, I only ever use it for segmentation. So that's what I'm going to show you today. So the first step that we're going to do in this process is we're going to import our data. We do that by clicking File and going down to Import Image Files. I'm going to hit Add. And I'm going to go ahead and go to a directory that contains all of my images, and I'm going to select all of the images in the sequence. This can also be an image stack, so if you have a single image stack, that's fine. And I'm going to go ahead and import those. I'm going to hit Next, and the one thing that I usually have to change is the pixel size. I like to make sure that that's right. And then I'm going to click Finish. It's going to load in. It's going to load in all of the data. And it should be stressed that the data that I'm loading into this session is the actual data that I'm going to segment, or at least some of the data from the data set that I'm going to segment. In this case, I've loaded in the whole data set, but in other cases you might just want to import 5, 10, 15 slices. Doesn't really matter when you're using the segmentation wizard. It'll work with either. So our data is just about loaded in. And the next step is going to be to create a segmentation wizard session. The way we can do that is by right-clicking our data over here in Data Properties and Settings, going down to Segmentation Wizard. So we can click that. Make sure your data set is selected and hit Continue. That's going to open up a window, a new window and this is your Segmentation Wizard session. In this session, we have a lot of different tools, a lot of different abilities, ways to manipulate the image. I think we're going to have future videos about some of these tools, like window leveling, which is very useful for getting rid of parts of the data, like the void that you don't want. But in this tutorial, what I'm mostly going to end up using is the ROI Tools section and the ROI Painter section, as well as everything over here to the right, where we'll be looking at all of our frames and all of our labels, classes, things like that. So we're going to start by creating our first training frame. The first training frame can be any region of the image, but this is going to be segmented by hand. I'm going to manually segment this data. So I like to make it very small, and I can train the model based on a very small region of the image. So I'm going to go ahead and zoom way in. This is just how I prefer to do it. You can do it however you want. And I'll click under Frames, I'll click Add. So what you can see this has done is it's created a very small region of the image. It's sectioned it off. And now this area I'm going to manually segment by hand, and that is going to get fed into the model. Now, I like to name my classes over here under Classes and Labels, so I'm going to designate green as fibers, maybe just fiber, and I'm going to designate pink as void. So I have a two-class material here. That is the fiber, and then anything that isn't fiber is going to be void. You can add classes by going down here and clicking Add. So if you had a third material, say you're dealing with something like Pika, which is fiber form that you see here with an added resin. This is a common TPS material. Then I would add a third material, and I would call this resin. Now, since I'm not going to be dealing with any resin or any other third class, I won't need that, so I can remove it. That's just for your future reference. So I'm going to go ahead and segment this manually by hand. This is really easily done using the Define Range feature over here. So I can click Define Range, and I like to start with the void. I'll hit Lower Otsu, and I'll go ahead and click my void here, and I will click down here, down to ROI Painter, and I like to use a circular paintbrush. well, I'll hold down Control. If you hold down Control, you can, and hit the mouse wheel, you can change the size of your paintbrush. And then to add to this class, I will click Control and click with my mouse. You might be confused at first because when you click, as you can see, it's not doing anything, but you have to hold Control and move the mouse, click with the mouse, and that will paint in all that region. You can also remove, so you can erase with Shift. So I'm now erasing by Shift clicking, Control click to add. So I'm going to go ahead and call this my void for now. And just as a side note, I always like to drag my void class down here as the background class. What this allows you to do is anytime you remove, say I remove some of the fiber material or in some region of the image, it will not leave it as blank pixels, but it will designate it to the background class, which is void. So when I erase fiber, it will become void naturally. It won't be just blank pixels that aren't labeled. And that's a really useful tip that I've found for making sure that all pixels are going to be designated to some material. Now, as you can see, the defining range tool, it did a pretty good job of capturing the void, but you can see that if we just designate the rest of it as fiber, it's going to pick up some regions that definitely aren't fiber. A lot in here, right? That's clearly not fiber. We can tell with our eye that's not fiber, that's just noise. And so this is the beauty of training a deep learning model. We can just make sure that our training data reflects that, and then our deep learning model will do much better than a simple thresholding segmentation can do. But for now, I'm going to go ahead and fix this. And just as a tip, if you can't tell, so like for instance, this region here, I'm not really sure if that's fiber or noise. So what I'm going to do is I'm going to scroll. And you know what? I think that based on this, is probably noise. And that the contrast, the enhanced contrast of the frame is probably just making it look like fiber. So I'm going to mark that as void. Okay, so now I'm going to go back to my define range tool, and I'm going to click upper Otsu, and I'm going to go ahead and mark the rest of this as fiber. I'm going to try to avoid hitting those noise patches that I just got rid of. So there we go. I'm going to unclick the define range tool, and now we have, for the most part, done a decent job segmenting the fiber from the void. I'm going to actually designate this here as fiber. We now have a decently segmented image. We've got some, maybe we can clean this up a little. So I like to click the fiber, and if I hit shift, that will, as you can see here, that will actually designate things as pink, as void. Those were blank pixels, I see. So it looks like we still have some blank pixels, so I'll go ahead and fix that. You want to make sure that all of your pixels are labeled with either fiber or void, or whatever your material is. You don't want to leave anything unlabeled. So this is our input image to train our model at first. Now that we have the data segmented manually, our first frame, I like to stop there if this is pretty characteristic of a large portion of the data. And I'm going to actually go over to models, and I'm going to generate a new model. And this can be done by clicking generate new models. There we go. And this is where you can kind of customize some of your model parameters, what model architecture you like to use. UNet is extremely simple. It's very fast. UNet is very good for two-class materials. So this is a two-class material. It consists of void and it consists of fiber. If you have more, UNet might work okay, but what usually ends up working better is a 3D architecture of some kind, like Sensor 3D or UNet 3D. For this example, I'm just going to use UNet, and I'm going to go ahead and click generate. So it says that it generated the model successfully. And now we're going to close that. If you want, you can actually generate multiple models and compare them to each other. I used to do this a lot with Sensor 3D, UNet, a few different kinds, UNet 3D. And it will train all of them in series, and then you can compare their performance. That really depends on how much time you have. If you're just wanting to create a really quick model, I recommend UNet. So this is my model here. It automatically names it. You can rename it if you want. I often do. I name it with the date and different information about what is being trained. And you can also customize a few things about the training session. I won't go over much of this. You can explore this if you want. I'm going to go ahead and click the model, and with one frame loaded, I'm going to go ahead and I'm going to click the model, and I'm going to click train. I have something on called early stopping. So as you can see down here in the log, it's giving you a lot of information about the val loss and the loss. And this is what's going to inform when it stops. As you can see here, it says early stopping in 9 epochs or 9 iterations, unless the val loss decreases. And this is just something that is default with Segmentation Wizard, that it will continue to run until basically it doesn't see any improvements for 10 iterations. And that's useful. That can be really useful if you're wanting a really quick model. Oftentimes, if I'm wanting a robust model, I just let it run for 100 epochs straight. That's up to you. You do not have to do that. Usually 10 gets you pretty much as good as it gets. So we're going to go ahead and wait this out, and once it's done training, we'll see what we get. So we've been training here for probably roughly 4 or 5 minutes, and you can see that we're halfway through our designated maximum number of epochs of 100, and the model keeps improving very slightly, but you can see that it's started to flatten out, and this is why early stopping is really useful. Early stopping kind of keeps it from just uselessly oscillating between certain loss values. It basically stops it when it's as good as it's going to get. I also want to note that the training, this number of steps it takes for me to train this, it's a lot less right now because the frame is very small. However, as we increase the number of frames, as we increase the overall number of pixels going into the training session, those steps are going to increase dramatically, and thus the training time is going to increase dramatically. That's the power of doing very small frames at first. That'll allow for quicker segmentation of newer and larger frames. So our training just finished up. Took a little longer than expected, but it was only probably 5 minutes. And so now it's going to load the model. It's going to evaluate the model, which is very useful for comparing different models to each other. It's actually going to give you a quantity to compare other models to. It's actually the score listed over here. So it looks like we have a score of 99.69. That basically means that 0.99, so 99% of the data matched any validation data it generated. That's not super meaningful right now because we have one training frame. That value is definitely going to go down as we give it more training frames. So what it defaults to immediately is it sends you this split screen. You don't need to click this for now, because what this is basically showing you is what its prediction is for how it would segment this training frame. And it's going to look pretty similar for this, but you can see some differences. Like right here, it's calling that fiber when I didn't. So it's got a few problems, but for the most part, it looks good. So I'm not going to click this because this will actually promote this image up to this training slice. I'm just going to double click my image and go back to my main training session. And so now I have one frame done. This is not enough data to train a robust model. You're going to want more than that because obviously there are other image features that I want to be able to train for. I want to be able to capture, for instance, if there are any image artifacts that I see that are problematic in the image that might confuse a model or confuse other methods of segmentation, such as thresholding. I might want to put some frames with those key artifacts or sections in. But I typically like to create maybe 3, 5, 10. It just depends on how well the model is doing. And I like to train kind of in steps, so I'll maybe do 3 or 4 more slices. I'll train it for a while, and I'll see how it does, and then I might add 3 or 4 more after that. But the real power of using a small slice is now I can give it a little bit more challenging of a region. So let's say I want to just I'll still keep it small, but I'm gonna go ahead and click add under frames. I'm gonna add a new frame, and I'm gonna see how it does. how this model is doing, and I'm going to use it to actually create more training data that I will then correct and clean up so that I can better train the model. And I'll do that by hitting predict. Okay, so it's done predicting, and you might be confused because it looks like nothing happened, but what you don't know is you just need to double click, and there is the predicted training data, the predicted new frame. And it didn't do a horrible job, but gosh darn it, I'm seeing a lot of noise that I do not like. I'm seeing maybe some parts that I would have filled in as fiber. And so this is a great starting place, but I'm going to go ahead and promote it. And I'm going to go back here, and I'm going to clean this up. I won't do this in depth here, but this would just consist of me removing noise, void that was mistaken for fiber, cleaning up some of the edges maybe, things like that. And once I am done with this slice, I can decide, well, maybe I want to retrain my model. It still won't take too long since I have new training data, or I can, if my model did really well, I can create 3 or 4 more training slices with the same model. And this is the power of this tool of Segmentation Wizard. It allows for very quick and rapid creation of training data and then directly training the model with that training data. It takes out a lot of the complications of tuning the knobs of the model, so it doesn't give you quite as much control. But it's really powerful for creating a really quick model. So the last thing that we're going to do is we are going to, now that we've trained our model, let's say we're done training it. I haven't done any more training. I would prefer to do 3 or 4 more training sessions. But let's say we're done. Now I can finish by clicking my model and going down here, clicking the floppy disk, and saving the model. I check the model, make sure the proper model is selected, and I hit save. Click OK. And now if we exit our Segmentation Wizard, I guess it's going to ask me to save the model. That's new. So it's going to save the session, which is really nice. I can return to the session at any time by just right-clicking and clicking Reopen Segmentation Wizard. So this here is actually a model that I've already trained with this data. And so I'll go ahead and I've marked this slice to segment. I will segment this data with this much more developed model, and we'll see how it does. And there it is. You can see that the model did a beautiful job distinguishing between noise and fiber, and it even does a pretty good job of finding the gaps in the fibers, distinguishing holes. But it's not perfect. It's still not quite perfect, and that's the problem. You're always going to have a little bit of error in these models, but it's much, much better than what can be done with just plain old thresholding. So if you're wanting to use this data, this segmented data, basically, let's say as a binary image, if you want to have it as a binary image, what you can do is you can extract the ROIs from the multi-ROI that was just created. I want to create an ROI from my fiber, for instance. That's what I like to do. So I'll right-click the fiber ROI that was just created, click Export, and I'll export the ROI as a binary. That's going to output a binary image where the fiber is going to be 1s and the void is going to be marked with 0s. That's going to do it for this tutorial, guys. I really appreciate you guys watching. If you have any additional questions, feel free to post it in the comments. Or you can also, if you know me, if you're part of the group, absolutely just feel free to reach out. I'm happy to talk more about this and help in whatever way I can. Thank you, guys. Bye.